In this STR8CHEM video, I'm going to walk you through with some problem solving in the coffee cup calorimeter. First of all, let's have a look at how we're going to have the coffee cup calorimeter to be assembled in a typical experiment. So we have a polystyrene cups, and inside the polystyrene cups you have water, and you're going to have the stirrer right over here. And the function of this stirrer is to make sure that the heat distributions inside this water of the calorimeter will be uniform throughout the experiment. And the thermometer that you're going to stick inside the calorimeter will be measuring the heat change inside. So this is a very simple diagram to represent what does a coffee cup calorimeter going to look like. Other names for coffee cup calorimeter is simple calorimeter and also the constant pressure calorimeter. So if you see these two names are being used in questions or in other notes, remember that they are referring to the same type of coffee cup calorimeter, and therefore they have the same principle. A few information that you need to know before we're going to start to look at some problem solving situation is this is a method that is quite popular if you want to find out what is the enthalpy of neutralization when you have acid and base mixing together to make 1 mole of water molecules. And also a few basic for thermochemistry that you need to apply in order for you to be able to solve some problem solving is the heat released by the system, the heat released by the reaction or system, which is represented by Q released, will be the same as the Q being absorbed, the heat's been absorbed by the surrounding. There are 5 possible Q absorbed situations. Number 1 is when you have Q, your heat, equals to m small c delta T. Number 2, when you have your Q equals to big C delta T. And then number 3, when you have your Q equals to mass times with the small c specific heat capacity times with delta T plus big C delta T. And number 4, when you have Q equals to mc delta T plus m small c delta T. And finally, the 5th possibility is when you have your heat absorbed, can be represented as the heat capacity times the change in temperature plus with the heat capacity times with the change in temperature. So we have 5 possibilities over here, but the one that I am marking with the star sign, those are the most popular ones that will be used in exams. Okay, so when you look at the start 1, 2, and 3, these are the most common, the most popular, going to be used in your examination. But note that it is not impossible for the examiner or the question wants you to find out for this type of Q and that type of Q. So how do you identify which one will be used for a certain question? You have to read through the question and find out the information available for you and use that information that is given by the question, and you should be able to identify which possibilities that you need to use. Okay, so let's have a look at the first question over here for coffee cup calorimeter. We have 150 centimeter cubic of potassium hydroxide solution with the concentration of 2 molar and 250 centimeter cubic of 1.5 molar hydroiodic acids, and they were mixed in a calorimeter. So when I see we have acids and base mixing together, automatically I know that this will be a coffee cup calorimeter. If the temperature rise is 10.2 degrees Celsius, we need to find out what is the enthalpy of neutralization for this particular reaction. The question gives you the specific heat capacity, which is 4.2 joule per gram per degree Celsius, and the density of solution 1.0 gram per centimeter cubic. And you will know later why the density of solution is given to you. So the first step that you need to do in this case, it's very important for us to have the balanced thermochemical equation written over here, because the question does not give you the balanced equation, so you have to write it. When you write the balanced equation, you should be able to get 1 mark. Okay, so that is the balanced equation, and you need to make sure, since this is going to be about enthalpy of neutralization, you need to make sure your water being produced to be equals to 1 mole. So that one needs to be 1 mole, since this is about enthalpy of neutralization. So you have to go back and look at the definition for enthalpy of neutralization, which is the heat release when 1 mole of water being produced when you have acid and base neutralize one another. Okay, so that is step number 1. So by writing the correct balanced thermochemical equation as such, you should be able to get, this one should be able to get 1 mark. And then for step 2, we need to find who will be the limiting reactant. Is it going to be the base or is it going to be the acid? Because in this case, you have 2 things reacting together, and the number of mole, one of them will be the number of mole of your water over this side when you do the proportionality later on. So that is the reason why we need to find who is the limiting reactant. And how are you going to do that? Since the question gives you the volume of your potassium hydroxide and the concentration, and you have the volume of your hydroiodic acid with the concentration. So what we can do is we can just do a very simple calculation to find the number of mole. So that is the number of mole of potassium hydroxide, KOH. So you get the molarity of your KOH times with the volume that is being used. So remember, you need to change the volume into liter, because based on the molarity definition, you have to have the volume of solution in liter. In the question, it is given to you in centimeter cubic, so you have to change that in liter first. Then you will get the number of mole for KOH, 0.30 mole. By writing that down correctly, you should be able to get another 1 mark. Okay, next you need to find out the number of mole for the acids, which is the hydroiodic acid, and you should be able to get something like this. So it's the same steps. You're going to be having the molarity of the hydroiodic acids multiplied by the volume of the hydroiodic acids, which is 250 centimeter cubic. But when you want to find the number of mole, you have to change that into liter or decimeter cubic, like what I have done over here. And you should be able to get 0.375 mole. And for that, you should be given another 1 mark. Now we have found out both number of moles. So when you compare both of them, since the ratio is 1:1, so you can directly compare the number of mole over here to identify who is the limiting reactant. KOH is 0.3, HI is 0.375, and that is obvious that your KOH will be the limiting reactant. Okay, so this over here, will be your, that is going to be your limiting reactant. Okay, so step 3, now we need to find out what is the number of mole of H2O. Why do we need to find the number of mole of H2O, because based on the definition for neutralization, we have to be concerned about the number of mole of H2O. So since KOH is your limiting reactant, so now we're going to compare the number of mole of your KOH with the number of mole of your water molecule on that side. So when you do that, step 3, when you do the proportionality, so this is a very simple proportionality. From the balance equation, we can have 1 mole of KOH, potassium hydroxide, to be making 1 mole of water molecule, okay? But in the question, we have 0.30 moles. We have 0.30 mole of KOH. So how much is that for water molecules being produced by the neutralization? So the number of mole of H2O, you should be able to get 0.30 mole as well. So for this whole thing over here, will give you 1 mark. Okay, so after that, we need to proceed to step 4. Okay, we have step 4 in which we need to find what is the value of Q being absorbed. The question now, which Q absorbed we need to use. Remember, when we talked about the 5 possibilities, we have possibility number 1, 2, 3, 4, and 5. And which one of these possibilities will be used for this questions over here? So the trick that we're going to apply in order for us to do this is to read the question and find out what is the clue, or what are the clues given to you for you to be able to identify which Q absorb you need to use. For this particular question, when you look at the question, we need to use Q equals to MC delta T. Q equals to mass times specific heat capacity times the change in temperature. Okay, why? Because the question gives you the specific heat capacity value. Okay, so the question gives you the specific heat capacity information right there. Okay, so it's just right over here given to you and nothing else. Okay, so you don't have heat capacity given to you, you don't have the information about other than specific heat capacity. Therefore, the one that we're going to use is this. So that's how you're going to be able to identify which Q formula that you need to use in order for you to solve a problem in thermochemistry. Okay, so it's important as well for us to know what does the question give. So the question gives you the information about mass of water or solution, okay, but it is not direct. What you need to do now, and it's very typical for neutralization, you need to have the volume of solution times with the density of solution. So that is the reason why the density of solution is given to you over here, because we're going to use the density of solution to find out the mass of solution, which is 400 grams. So what you need to do over here, you have 150 plus 250, and the information is right there. When you add the potassium hydroxide together with the 250 centimeter cubic of hydroiodic acids, the total volume of the whole solution would be equals to this, okay? And the total volume right there, when you times with the density of solution, you would be able to get the mass of the solution. And this information afterwards, you need to put that into here. Okay, and then the specific heat capacity is given to you, and you have the delta T as well. So you have the change in temperature, which is 10.2 degrees Celsius. Okay, 10.2 degrees Celsius, delta T, and we just gonna take all of this information that you have got, and you're going to substitute into the formula like this. Then you get Q equals to 400 times 4.2 times 10.2. So this is the change in temperature. And you get Q value equals to 17136 joule, and you have to convert that into kilojoule. Okay, by doing that, by having this correct Q used, you have 1 mark. By finding out the mass of solution, you have 1 mark, and by getting the value of Q, you have another 1 mark. We are not done yet, because our job is to find out the enthalpy of neutralization. Now we have found the Q value, and also you have found the number of mole of water. So we're going to use both information, and we will be doing step number 5, in which to find the delta H, which is the one that we need to do right here, enthalpy of neutralization. Okay, to find the delta H for neutralization, we have to use the formula of Q over N. Okay, Q over number of mole of water in this case. So it's very simple. So you're going to have the delta H neutralization like this. Okay, so you have delta H neutralization minus, the reason why you have the minus sign over here, because if you go back to the definition of enthalpy of neutralization, it says that the heat's released. Okay, so neutralization will always going to be exothermic. So for neutralization, you have to remember, you need to have this sign right there, negative, because neutralization is exothermic reaction for neutralization. So you're just going to plug in the values of which that we have got in the previous steps. You have your Q value, which is 17.1 kilojoule right here. Okay. And you're going to divide by the number of mole of water. So that is the number of mole of water. So that is the number of mole of water that we have figured out in the previous steps. And finally, you should be able to get your delta H neutralization, which is negative 57.0 kilojoule per mole. You need to make sure you have the negative sign in front. Without the negative sign, you will not going to be able to get your 1 mark. So by using this formula, this whole thing over here, you will get 1 mark. And to conclude your answer, you have to write together with the whole thermochemical equation like this. Okay. Do remember the negative sign, because this is heat or enthalpy of neutralization, exothermic reaction. And thus, with this, you get another 1 mark. So let's have a look at another question on neutralization. So right here in front of your screen, as you can see, the questions already gives you the balanced equation. Therefore, we don't have to do that anymore. So for this bit over here, you will not going to get any mark because the question has given to you. So step 1 would be for us to find the limiting reactant. And how do you find that? It's the same as what we have done before. Okay, so what we need to do now, we have to find out the number of mole of the acid. Okay, so how do you do that? Exactly like what we have done just now. We have 1 molar of acid here, 50 ml. And then by finding out what is the number of mole of your HCl, you get 1 mark. Okay, so you have 1 molar of HCl times with 50 ml. Remember, change ml into liter, decimeter cubic. Before you want to do the calculation over here, you should be able to get 0.05 mole. And since this is neutralization, we have NaOH. So when you look at the information for sodium hydroxide, you have 1 molar of sodium hydroxide, the same volume as well. So you can see that over here, the sodium hydroxide will have the same number of mole as well. Okay, so you take the molarity times with the volume that is given to you, you get 0.05 mole as well. So this is another 1 mark. So which one of these two species would be the limiting reactant. Since the ratio from acid to base is 1:1, you can directly compare the number of mole over here. Since they have the same number of mole, both will be the limiting reactant. So the limiting value would be equals to this. Okay, so that is the limiting value. Both of them will be the limiting reactant. So moving on to step 2, after we have figured out what is the limiting reactant value. So in step 2, we're going to find the number of mole of water. We're going to use the same proportionality method right over here. I picked HCl. You can use NaOH as well because you have the same number of mole over here. That should be okay. And you would be able to conclude that the number of mole of water would be 0.05 mole. By doing so, you should be given, for this whole thing that you have done over here, proportionality and finding the number of mole of water, you would be able to get another 1 mark. So now we're going to find out what Q absorb that we need to use. Okay, so when you read the question further, you would realize that the only information given to you about which Q will be used is this. You have the specific heats of solution are close to that of water, which is 4.18. Okay, so that is the only thing that is given to you. There's no heat capacity is given, so only specific heat capacity. Therefore, what we need to use is Q equals to MC delta T, since the question gives you specific heat capacity only. Okay, so to solve that, we need to look at what the question gives. The question gives the information about mass. Okay, same like what we have done in the previous example just now. You have the volume of solution times the density of solution, which is 1 right here. The density of solution is given to you. Okay, the density of solution is 1 right there. Okay, and the volume of solution is when you have 50 HCl plus with 50 ml of NaOH. So when you add them both, 50 plus 50, you have 100 ml. That is the volume. When you times with the density of solution, you would be able to get the mass of your solution. And that should be able to give you another 1 mark right there. Okay. And of course, you have the information of specific heat capacity. So this is the specific heat capacity. And the temperature change is right over here. Okay, right now, the temperature of the mixture increased too. Okay, you have to read the question carefully. It's slightly different from what we had in the first example. So the temperature increased to 35.4. And initially, the temperature is 28.5 degrees Celsius. So what you need to do for the change in temperature, you need to take the final temperature, increase 2, minus with the initial, and you should be able to get the delta T. If you look at the previous example just now, it used slightly different kind of word. Okay, the use, if you look here, it uses the word temperature rise is 10.2. So that is how much the temperature has risen. Okay, so you have 10.2. But in this particular example, the question used the term the temperature increased to 35.4 degrees Celsius. So you have to be careful about that one when you want to do this type of question. So when you substitute all the value inside the Q formula, you should be able to get this. So we have 1 mark for the correct formula that you are used, and you have 1 mark for finding out the value of Q in terms of kilojoule. Now, step number 4, we're going to use the Q over N, the value of Q over mole, to find the delta H. Okay, so our mission for this question is to find out the enthalpy of neutralization. Okay, so it's the same as what we have done in the first example. So we're going to use this formula. And remember to have the negative sign because this is neutralization, it's exothermic. And you put the value of Q, of which you have found right here, value of Q. And you divide by the number of mole of water. Okay, so that is the number of mole of water that you have found out just now. And this one is the value of Q. Then you get delta H neutralization equals to negative 57.6 kilojoule per mole. You need to have the units to be written correctly. So this whole thing would give you 1 mark. And finally, to conclude your answer, you're going to write the whole thermochemical equation, okay, like this, and you would be able to get another 1 mark. Now we're going to look at one example that is a non-neutralization, but it is still going to be about coffee cup calorimeter. You are given a situation over here in which you have pure sulfuric acid dissolved in water, and when that reaction happens, exothermic reactions happen. So the process adding your sulfuric acids into water to make it slightly diluted, it will release a certain amount of energy. And the energy being released when you do that process is this, okay? So this is not neutralization, obviously, because when you look at the balance equation, you do not have a base. You just have a pure sulfuric acids added dissolved in water to make sulfuric acid aqueous. Still, this one is still going to be using calorimeter. Why? Because it used the word calorimeter over here, and you have the word water being dissolved in pure sulfuric acid. So nothing is being burned. Okay, nothing is being burned. If you want to use bomb calorimeter, the sulfuric acid will be burned. But in this case, you have the sulfuric acids and the water add together, and the reaction of adding sulfuric acid and water will release heat. And that heat being released can be measured by using a coffee cup calorimeter. So, step number 1, we need to find out what is the number of mole of sulfuric acid first. And how do you do that? You're going to take the mass of sulfuric acid being diluted and divide by the molar mass, and you should be able to get the number of mole of sulfuric acids equals to 0.153 mole. So by finding that out, you would get 1 mark, okay? And then step 2, by using the information that we have over here, we need to find out what is the volume of Q. Why do we need to find the volume of Q? Because when you look at the question wants you to find the final temperature of solution. Okay, so if you want to find the final temperature of the solution, we need to know what is the value of Q for this reaction. So step 2, we're going to find the value of Q. All right, so you're going to take the delta H value, of which you have over here, negative 73.7 kilojoule per mole. And we're going to use the formula right there. Delta H equals to Q over number of mole of sulfuric acid. And when you use this formula to find out the value of Q, you can ignore the negative sign, because the negative sign over here is simply to show that it is exothermic. But when you want to use this information to find out the value of Q, you can ignore the negative sign. So I have ignored the negative sign. I'll just put that information inside the formula, and I get the value of Q equals to 11.33 or 327 kilojoule. I've got kilojoule over here because you've got kilojoule right over there. So by doing that, this whole thing here, you should be given 1 mark for that. Okay, so we have found out the value of Q. Now, which Q absorb that we need to use? So the answer is we're going to use Q equals to MC delta T. Why? Because the question gives you specific heat capacity, and another extra information the question gives you is that there is no heat loss to the calorimeter. That means all of the heat being released by the process is absorbed only by the water inside the calorimeter. Okay, so when you look at the question, it gives you specific heat capacity and also no heat is lost to the calorimeter. So after we have found out the Q equation that we need to use for this particular reaction or question, we're going to use this, and we need to find out what our other information question gives. Over here we have found out the mass. Okay, the mass of water is 500 mil, like what you have been given right there. Okay, 500 mil of water, and we're going to convert that into mass. You're going to times with the density of water. So this is the, okay, so that is the density of H2O. That is a constant, and you should be able to memorize that by now for density of water. And you get the mass right there. For finding the mass, you get another 1 mark. Okay, and you have the specific heat capacity and the delta T that you need to find right there. And this is the one that you are going to be looking for, T final. And 25 degrees Celsius is given to you, which is right there. Okay, and we want to know how much temperature going to be increased when you have this reaction happens. So next, step 3, finding the T final. So what you need to do now, you're going to use Q equals to MC delta T, and you're going to substitute all the value inside. So you have 500 grams times with 4.18 joule per gram per degree Celsius, and you have the delta T. So when you do this calculations over here, you should be able to get the delta T value equals to 5.4 degrees Celsius, and this one will give you 1 mark for finding the value of delta T. But our mission is to figuring out the final temperature of the solution after you have the sulfuric acids turn into sulfuric acid aqueous when you add water with that. And how do you do that? It's a very simple mathematical process. You're just going to be adding. You're going to take 25. 25 is the initial temperature, and you're going to plus with 5.4 the delta T, and you get T finals equals to 30.4 degrees Celsius. So that is the answer that you need, and thus for that you get another 1 mark.